In this video, we're going to talk about phase shift and vertical shift as it pertains to trig graphs. As you already know, there are four kinds of transformations that we can apply to graphs of trig functions. We've already talked about A, which is our amplitude, and B, which is our period modifier and what tells us the frequency of the function. We've talked about those two. And so what we're really going to focus on in this video is the C and the D value. So this C thing here, which could be added or subtracted, that is in the parentheses behind your variable. So it's not the number attached to the variable, but it's either plus something. That's going to be our phase or horizontal shift. So that's something that shifts along the x-axis, either to the right or to the left. And also, keeping in tradition with transformations of functions, if it's a positive, remember, if you're manipulating the x, it goes backwards to what your intuition is going to tell you. So if it's plus some number right here, it's actually going to go to the left, and if it's a minus, it's going to go to the right. Now the thing that doesn't play with your brain is vertical shift. So that's something that's either at the very end or at the very beginning of your function. It's not attached to anything else. It's either plus or minus some number. So that means that it's a vertical shift. It's either going to go up or down along the y-axis. And that, like I said, goes with your intuition. If it says plus 2, it goes up 2. If it says minus 5, it goes down 5. So I want to explicitly go over how to find phase shift and vertical shift algebraically just given a function. So let's say I have this function here. Y is equal to 3 sine parentheses 2x minus pi and parentheses plus 5. So what I'm going to do is I'm going to label my A, B, C, and D and then go about finding the shifts that I have. So luckily these things are in order of A, B, C, and D. A and B here, I'm not going to focus on because I just want phase shift and vertical shift. So I'm going to focus on this C value, which is negative pi, and this D value here, which is plus 5. So the thing that's vital to finding your phase shift is actually getting this number in front of the x to be 1 so that we can actually find the phase shift all by itself. So what I mean by that is, do you notice that there's a 2 in front of the x? I'm sure you do. So if I divide everything in these parentheses by 2, that gives me 1x, and that pi becomes pi over 2. So another way you can check that if you're not sure if you did that correctly is you could distribute the 2 back. So 2 times x is 2x, and 2 times pi over 2 is pi. So we always want to make sure to get this x variable by itself to have a 1 in front of it. So that means the phase shift is actually pi over 2, not pi. So there are two ways that you can express phase shift. Traditionally, it's just written as like phase shift or PS is equal to pi over 2, for example. But you might notice that there's a minus there. So we know that a minus next to an x is going to manipulate it to go to the right. Phase shift is written literally, which is really confusing if you think about it. So you can either write it like this, like pi over 2, or what I find to be more useful is just forgetting about the negative and the positive and writing what direction it's going to. So for me and in my class, I will accept pi over 2 to the right for your phase shift. But if you take a trig class with anybody else, they may want you to know that phase shift has to be the opposite of whatever that sign is. So now let's take a look at vertical shift. So vertical shift, like I said, is straight up whatever it says here. So it's plus 5, that means that vertical shift is 5. And really what that does to our graph is it shifts the midline. Instead of being the x-axis or y equals 0, it moves it up to y equals 5. So everything will operate from that midline instead of the x-axis. And here, graphically, is how all those shifts occur. So the first thing that I would do is graph the midline at y equals 5, and then I would figure out what my period is going to be, so that's 2 pi over 2, so that is pi. And so if I'm going to chunk that up into 4 sections, I'm going to want to count by pi over 4. So that means that a pi over 2 shift to the right will start my sine function here. It'll go to 3 pi over 4, because pi over 2 plus pi over 4 makes 3 pi over 4, and then every key point from there is pi over 4 from the previous point. So you just add pi over 4. That's what I'm trying to say. And of course, the amplitude here goes up from 2, goes all the way up to 8. 5 plus 3 is 8. Goes all the way down to 2 because 5 minus 3 is 2. So that's how all those shifts come together for this function. So let's do another one, just so that we have enough practice under our belt for finding phase shift and vertical shift. So let's say I have this function here. I've got y equals 2 cosine parentheses 4x plus 3 pi and parentheses minus 1. Now I'm going to rewrite it because I notice that that's not a 1 in front of my x. All right, so what I've done first is identify A, B, C, and D. Luckily it's in the same order, alphabetically, which is nice. So remember, I have to pull out whatever number's in front here, and essentially I just divide this guy by that same number. So if I pull out a 4, I have to divide this by 4, because again, if I distribute it back, it gives me that. So that means that my phase shift is 3 pi over 4, so you could either say, again, negative 3 pi over 4, which means that you change that sign, or you can use a few more words and just say that it is 3 pi over 4 to the left, because that's positive, it's going to shift that thing to the left, because x is tricky. And vertical shift is what it is. It's negative 1, which moves your midline down to y equals negative 1. So if you look at the graph, it actually represents all of these changes. So the midline bumps down to negative 1, and I've got a phase shift all the way to negative 3 pi over 4. And so cosine always starts up, so it's going to start 2 up from the midline, and then it's going to complete a full cycle in 2 pi divided by 4, or pi over 2. So from negative 3 pi over 4 to negative pi over 4, that's 2 pi over 4, or pi over 2, which completes one cycle in that period. So when you go to graph this thing, it's a-okay to just graph starting here. You don't always have to start at the y-axis. All right, so now we are going to put all of our trig graph knowledge to the test and graph a function with an a, b, c, and d. We're going to graph one full cycle of this function here. So we've got 3 cosine parentheses 2x plus pi over 2 and parentheses minus 1. So we're going to graph one cycle of this. We're going to label 5 key points and the midline. So let's break this thing down. So I've identified my a, b, c, and d, and I've rewritten my function to pull this 2 out in front. So when I divide pi over 2 in half, that becomes pi over 4. So here's what I have so far. The amplitude is going to go up and down 3 from the midline. The period is 2 pi over 2, which is just pi. The phase shift is pi over 4 to the left. And my midline now drops down to y equals negative 1. So I'm going to go about labeling my y-axis here. I'm going to make some notches along here, and we'll go from there. So I know that my y-axis needs to cover from negative 4 all the way up to positive 2, because if your midline is at negative 1, plus 3 is positive 2, and minus 3 is negative 4. And I've got a good amount of space here, and I only need to graph one cycle. And so I only needed to chunk up 4 chunks, as I like to call it, right? So 4 here, 4 here, 4 here, 4 here. So that's going to give me plenty of space. So I'm going to label my x-axis last, as I like to do. And so the first thing I'm actually going to graph here is my midline, because everything's got to go up and down from there. So when you graph your midline, it's like any other horizontal line, and you just want to label it there. You can actually color code it if you prefer. So that's where everything's going to operate from. No longer am I going to go like 3 up and 3 down from the x-axis, because the midline has been shifted. This is my new quote-unquote x-axis. So here's how I was able to put in those 5 key points. Now I haven't labeled my x-axis yet, but I happen to know that the period is 1 pi. And if I have to split that into 4 different chunks, that makes it pi over 4. And if I actually shift this thing pi over 4 to the left, that means that my cosine, instead of starting up here, will start pi over 4 to the left of the y-axis. So that must mean that every single one of these markers is pi over 4 from the next one. So that's going to help me figure out my points and label my x-axis. So from here, I've connected them into a kind of cosine-looking shape. It makes that U. It starts down here, goes all the way up here, and then I just fill in my x-axis. So that is negative pi over 4 because that's how much I shifted it. And then it's 0 pi over 4, 2 pi over 4, just same as pi over 2, and then 3 pi over 4. So this distance, which is a pi over 4 plus 3 pi over 4, makes a full 1 pi. So I've made one cycle, shifted it down and also to the left, and here we go. So these are my 5 key points. And that's it. All right, that's going to do it for this video. Thanks for watching.